From this video, we shall learn how to solve the system of linear equation by Jacobi method solving one example. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Solve the system of equation 5x minus y equal to 9 minus x plus 5y minus z is equal to 4, y minus 5z is equal to 6. By applying Jacobi method, taking 1.8, 0.8 minus 1.2 as initial approximation to the solution. That means you need to consider x0 is equal to 1.8, y0 is equal to 0.8 and z0 is equal to minus 1.2. If this has been not given, then you need to consider x0, y0 and z0 as 0 and you have to start solving. So before solving, first check whether the system of equation is diagonal dominant. So first we need to check in the first equation the coefficient of x is not 0. So the coefficient of x is 5. Then in the second equation the coefficient of y, we need to check it is not 0. So coefficient of y is 5, which is not 0. And in the third equation you need to check the coefficient of z, it is minus 5 and it is not equal to 0. Then next you need to check the diagonal coefficients are greater than the coefficients of the non-diagonal coefficient of a given equation. That means consider first equation, coefficient of x is 5 and coefficient of y is minus 1. So you need to take the modulus. So modulus of 5 is greater than modulus of minus 1. That is the 5 is greater than 1. And z coefficient is not given, that means it is 0. So 5 is greater than 0. The first equation is diagonal dominant. Then in the second equation you need to check with y coefficient. Y coefficient is 5 whereas x coefficient is minus 1. Take the modulus. Modulus of minus 1 is 1. So 5 is greater than 1. Then next 5 of the second equation, that is a y coefficient is 5 and z coefficient is minus 1. So modulus of 5 is greater than modulus of minus 1 because 5 is greater than 1. So now it is also a diagonal dominant. Then consider the third equation, minus 5z. You need to take the modulus of minus 5. Modulus of minus 5 will be plus 5. E is greater than the coefficient of x. So since x term is not given, that means the coefficient is 0. So 5 is greater than 0. The next coefficient of y. So 5 coefficient of y is 1 and coefficient of z is minus 5. Modulus of minus 5 is plus 5. So plus 5 is greater than 1. Therefore the given system of equation is diagonal dominant system. That means this system of equation we can solve by using Jacobi method. If it is not a diagonal dominant system, try by interchanging the equations, you get the diagonal dominant system. Then also if you don't get, that means you cannot apply the Jacobi method. Now solution, consider 5x minus y is equal to 9 minus x plus 5y minus z is equal to 4, y minus 5z is equal to 6. Since we have checked it is a diagonal dominant system, consider this system, that is the system of equation, as 1. This is the system of equation 1. Now rewriting the system of equation 1 as the first equation, consider 5x minus y is equal to 9. So we can write 5x is equal to 9 plus y, taking y to the right hand side. So it will be minus y. If it goes that side, it will be an plus y. That is 5x is equal to 9 plus y. We can write x is equal to 1 divided by 5 into 9 plus y. Then next consider the second equation. minus x plus 5y minus z is equal to 4. So it can be done as 5y is equal to 4 minus x, when we take to the other side it will be a plus x, minus z, when we take to the other side it will be a plus z. Therefore 5y is equal to 4 plus x plus z. Therefore what we can write, y is equal to 1 divided by 5 into 4 plus x plus z. The next, consider the third equation in the system of equation 1. Y minus 5z is equal to 6. So it can be done as minus 5z is equal to 6 plus 6 minus y, because it is a plus y. When we take to the other side it will be a minus y. That is minus 5z is equal to 6 minus y. Therefore what we can write, z is equal to minus 1 divided by 5 into 6 minus y. And consider this set of system of equation as 2. Now first approximation, we start with x naught is equal to 1.8, y naught is equal to 0.8 and z naught is equal to minus 1.2, because these are the initial values which has been given in the question. So therefore we consider these as x naught, y naught and z naught, putting them in equation 2. That means replacing x, y and z value on the right hand side of an equation 2 with 1.8, 0.8 and minus 1.2, we get x1, y1, z1. So first x1 is equal to 1 divided by 5 into 9 plus y is 0.8. So 9 plus 0.8. So while calculating in the calculator, you can write, open the bracket, 9 plus 0.5 divided by 5, because into 1 will be same, for that purpose just divided by 5. Or else you can also write, open the bracket, 9 plus 0.8, close the bracket, divided by, open the bracket, 1 divided by 5, close the bracket. Or else just you can write, open the bracket, 9 plus 0.8, close the bracket, divided by 5, and it will give the answer, and that answer is 1.96. The next we need to calculate y value, is the y1. y1 is equal to 1 divided by 5 into 4 plus x value is 1.8 and z value is minus 1.2. That is y1 is equal to 1 divided by 5 into 4 plus 1.8 minus 1.2. In the calculator, while calculating, you can write, open the bracket, 4 plus 1.8 minus 1.2, close the bracket, divided by 5, and you will get the answer, and that answer is 0.92. The next, z1 is equal to minus 1 by 5 into 6 minus 0.8, because the y value is 0.8. While calculating, you can write, open the bracket, 6 minus 0.8, close the bracket, divided by, open the bracket, use small minus sign which is present in the calculator, and write 5, close the bracket, and you will get the answer, and that answer is 1.04. So these are the values of x1, y1, z1. These values you have to consider for the second approximation. From the first approximation, we got x1 value as 1.96 and y1 as 0.92 and z1 as minus 1.04. Substituting these in right hand side of an system of equation 2, we get the second approximation, that is x2, y2 and z2 values. First, x2 is equal to 1 divided by 5 into 9 plus 0.92. While calculating, you can write, open the bracket, 9 plus 0.92, close the bracket, divided by 5, and it will give the answer, and that answer is 1.984. The next, y2 is equal to 1 divided by 5 into 4 plus x value is 1.96 and z value is minus 1.04. So while calculating in a calculator, you need to write, open the bracket, 4 plus 1.96 minus 1.04, close the bracket, divided by 5, and that answer is 0.984. The next, Z2 is equal to minus 1 divided by 5 into 6 minus y is 0.92. And in the calculator you need to write, open the bracket, 6 minus 0.92, close the bracket, divided by, open the bracket, small minus sign, then 5, close the bracket, and that answer will be minus 1.016, minus 1.016. X2 is 1.984, Y2 is 0.984, and Z2 is minus 1.016. From the second approximation, we got X, Y and Z values as 1.984, 0.984 and minus 1.016. Substituting these values on the right hand side of a system of equation 2, we get X3, Y3 and Z3. So first, X3 is equal to 1 divided by 5 into 9 plus y value is 0.984. Close the bracket. While calculating, open the bracket, 9 plus 0.984, close the bracket, divided by 5, and that answer is 1.9968. X3 is equal to 1.9968. Now calculate y value. So y3 is equal to 1 divided by 5 into 4 plus x value is 1.984 plus z value is minus 1.016. Close the bracket. While calculating, open the bracket, 4 plus 1.984 minus 1.016, close the bracket, divided by 5, and that answer is 0.9936. Next, Z3 is equal to minus 1 divided by 5 into 6 minus y value. Y value is 0.984. Close the bracket. While calculating, open the bracket, 6 minus 0.984, close the bracket, divided by, open the bracket, small minus sign which is present in the calculator. After that, 5, close the bracket, and that answer is minus 1.0032. So these are the values of X3, Y3 and Z3. Now we need to go for a fourth approximation by considering these values. From third approximation, we got X value as 1.9968, Y value as 0.9936 and Z value as minus 1.0032. By substituting these values in the right hand side of an equation, system of equation 2, for x, y and z values, we get the fourth approximation x4, y4 and z4. That is, substituting x3, y3 and z3 in the place of x, y and z on the right hand side of an equation 2, we get x4, y4 and z4. So first, x4 is equal to 1 divided by 5 into 9 plus y value is 0.9936. So in the calculator you need to write, open the bracket, 9 plus 0.9936, close the bracket, divided by 5, and that answer is 1.9987. The next, y4 is equal to 1 divided by 5 into 4 plus x is 1.9968, then z minus 1.0032. So in the calculator, open the bracket, 4 plus 1.9968 minus 1.0032, close the bracket, divided by 5, and that answer is 0.9987. The next, z5 is equal to minus 1 divided by 5 into 6 minus y is 0.9936. In the calculator, open the bracket, 6 minus 0.9936, close the bracket, divided by, open the bracket, small minus sign, after that 5, close the bracket, and that answer you get is minus 1.0013. So these are the values of x, y and z at the fourth approximation. Now we shall move on to the next approximation, that is the fifth approximation. Now moving on to the fifth approximation, we got x4 value as 1.9987 and y4 as 0.9987 and z4 as minus 1.0013 in the fourth approximation. So substituting x, y, z, these values on the right hand side of an equation 2, that is a system of equation 2, we get x5, y5 and z5. So first x5 is equal to 1 divided by 5 into 9 plus 0.9987. As I told how to calculate, based upon that when you calculate it will give the answer 1.9997. The next y5 is equal to 1 divided by 5 into 4 plus 1.9987 minus 1.0013. Upon simplification you will get 0.995. Then z5 is equal to minus 1 divided by 5 into 6 minus 0.9987. Upon simplification it will give the answer, and that answer is minus 1.003. These are the values of x5, y5 and z5. Now we shall move on to the sixth approximation. From the fifth approximation we got the values of x as 1.9997, y as 0.995 and z as minus 1.003. X value as 1.997, y value as 0.995 and z value as minus 1.003. Now substituting these values on the right hand side of a system of equation 2, we get sixth approximation, that is x6, y6 and z6. So first x6 is equal to 1 divided by 5 into 9 plus 0.995, because the y value is 0.995 from the fifth approximation, and upon simplification this will be equal to 1.49. Then next y6 is equal to 1 divided by 5 into 4 plus 1.997 minus 1.003, because the x value is 1.997 and z value is minus 1.003, which we got from the fifth approximation. So now upon simplification y6 will be equal to 0.49. Then z6 is equal to minus 1 divided by 5 into 6 minus 0.995. So upon simplification this will be equal to minus 1.0001. Now you can observe x5, x6 are almost nearer, y5 and y6 are almost nearer, z5 and z6 are almost nearer. That means the values of the fifth approximation and at the sixth approximation are almost same. Therefore we can stop iterating. That means this approximation finding can be stopped, and whatever the values we get at the sixth approximation for x is 1.49, this is nearly equivalent to 2 upon rounding off to one significant digit. Then y equal to 0.49, which we got at the sixth step, and it is nearly equivalent to 1. Then z is equal to minus 1.0001, which we got at the sixth step. This one is nearly equivalent to minus 1. Therefore x is equal to 2, y is equal to 1 and z is equal to minus 1, or the solution of system of linear equation 1 by applying Jacobi method. That is, we have calculated the values of x, y and z by using Jacobi iteration method. Verification of the answer we got. So we can do the cross verification of the answer which we have got by applying the Jacobi iteration method, whatever the answer we got, those answers we can substitute in the equation and we can cross verify that the answers we have got are correct. So now consider the first equation, which is 5x minus y is equal to 9. Consider LHS. So LHS is 5x minus y. Now the x value is 2, y value is 1 and z value is minus 1, which we have calculated. Substitute those things in this one. So therefore we can write 5x minus y can be written as equal to 5 into 2 minus 1, because x value is 2 and y value is 1. So 5 into 2 is 10, 10 minus 1 is 9, therefore it is equal to 9. That means RHS. We have considered LHS and we have got RHS. That means whatever the values we have got is correct for the first equation. Now the second equation is minus x plus 5y minus z is equal to 4. Consider LHS. LHS is minus x plus 5y minus z. So now substitute the values of x, y and z. Therefore we can write equal to minus 2 plus 5 into 1 minus of minus 1. So minus 5 into 1 is 5, 5 minus 2 is 3, then after that 3 minus of minus 1 is plus 1. So 3 plus 1 will be equal to 4. Means we have got RHS. LHS is equal to RHS. That means the values which we have found is correct for the second equation also. Now we shall move on to the third equation. The third equation is y minus 5z is equal to 6. Consider LHS. Y minus 5z. Substituting here, so it will be equal to 1 minus 5 into minus 1, because y value is 1 and z value is minus 1. Minus 5 into minus 1 will be plus 5, plus 5 plus 1 will be equal to plus 6. Therefore it is the RHS. LHS is equal to RHS. That means whatever the answer we have got is correct for the third equation, and for all the three equations whatever the answers we have got is correct. Therefore x is equal to 2 and y is equal to 1 and z is equal to minus 1 are the correct or an exact values for a given system of linear equation by using Jacobi method. It is also called as a Jacobi iteration method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.